Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on antenna. This video, I'm going to explain what is actually antenna radiation pattern. I'm going to explain with practical example so that this can be understood by a beginner. So this will be the objective of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, I actually prefer you guys to ask me your question through the comment. So let's start. In antenna engineering, okay, the radiation pattern, okay, so this is actually the radiation pattern. In fact, they are one of the most important characteristics because it directly describes the spatial distribution of transmission power. Okay, for example, this is actually the distribution of transmission power and also the direction from which signal can be effectively received. From here, you can see that this is a very directive antenna. They basically beam the so-called receiver at certain direction, okay, which is the Z-axis. The radiation plot, in fact, provide a visual representation of the RF energy that is radiated by or, in fact, received by an antenna. Okay, so these measurements are conducted in a specialized test facility designed to isolate the antenna from external radio frequency interference. Okay, so basically you can see that this is in fact an antenna chamber. Okay, basically they isolate. Okay, in short, nothing can come from outside into the chamber and nothing inside the chamber can escape to the external world. Okay, although factors such as cable type, cable length, and the numbers of cable joints or connector, in fact, they can influence the signal performance. They are not considered in this measurement. Okay, so basically, in short, we can actually look at the antenna pattern in this three direction, which I'm going to explain further. The image over here shows a set of plot, and also there is actually a guide to the direction in which you are actually looking at. Okay, so basically, let's come into a little bit more detail on this SZ plane. Okay, so basically, this is actually when you actually look at this direction, this is the location of the antenna. You actually look into the 2D radiation pattern of the antenna. So over here, you can see that there are many different colors. The many different color actually will be the different frequency. When they are actually at different frequency, the radiation pattern can be very different. So basically, in short, the different color actually represent the frequency over here. So basically, this is actually the 2D so-called plot at the SZ plane over here. So this is the 2D plot at the YZ plane over here. And this is actually the XY plane when we actually look from the top. Okay, so basically these are the radiation pattern in 2D. Let's take a look on isotropic antenna. Okay, so in fact they are known as perfect antenna. Why? Okay, because they emit energy around a sphere equally, as you can see from here. The antenna, okay, will be located right at the center of this sphere. In reality, okay, no antenna can do that, which means that this is a perfect antenna which don't exist. Okay, so in fact, even if it really exists, we do not want it because it actually will waste a lot of energy. Let's understand the radiation pattern. Okay, so basically we can take a look, okay, on the front view, take a look on the side view, and take a look from the top view. So this is what we know as SZ front view or YZ side view and XY top view. Okay, so basically since this is isotropic antenna, like I mentioned earlier on, they will be evenly so-called radiate out. So they will be in a spear shape. So therefore, in short, whether it is SZ, YZ, or XY, the radiation plot will be perfect. So this is actually for isotropic antenna, okay, which means that they actually radiate equally everywhere. So regardless of SZ, YZ, or XY plot, they will be looking a complete perfect circle. Okay, so basically this is actually the radiation pattern for isotropic antenna. Next, I like to explain the radiation pattern of omnidirectional antenna. So this is actually a typical omnidirectional antenna. Okay, dipole also consider a omnidirectional antenna. This is actually the radiation pattern for omnidirectional antenna. So in short, if you look from the top, there will be a hole right at the middle. How does the RF energy actually radiate? Okay, will be looking like this. They basically will be so-called radiate up from the antenna, around the antenna, as you can see from here. So this is how they release the RF energy. So next, let us take a look on the XZ plane, YZ plane, and also the XY plane. Let's come to the XZ plane over here, which is the front view. Okay, so basically looking at the front view of the radiation pattern of this omnidirectional antenna. Like I mentioned earlier on, this is in fact like a donut shape. When I actually look at the front view, they will be looking something like this. Okay, so basically this is actually the front view of the omnidirectional antenna. Let's take a look on the YZ plane, okay, so which is at the side view. Okay, so whether it is at the front view or whether it is at the side view, you can see that the radiation pattern is almost identical, as you can see from here. So this is for the SZ plane and also the YZ plane, looking at the front view and also at the side view. When we actually look at the XY view, okay, which is right from the top view here, it will be slightly different. When we actually look over here, like I mentioned earlier on, there will be a hole at the middle, and basically you can see the whole of the radiation pattern of the omnidirectional antenna. So this is in fact the radiation pattern for omnidirectional antenna. Now, let me focus on small omnidirectional antenna. So in fact, to conclude, it is also quite similar with omnidirectional antenna, except that it is not that perfect. Again, you can imagine that this is actually quite similar with donut radiation pattern from the omnidirectional antenna. How they release the energy again will be around the antenna. Okay, for example, this whip antenna can be a small omnidirectional antenna. Let's take a look on the radiation pattern again on the SZ plane, on the YZ plane, and also on the XY plane. Let's take a look on the SZ plane, which is the front view. Okay, so basically this is actually the front view. Okay, so like I mentioned earlier on, it is almost not that perfect. Okay, but it is quite similar with omnidirectional antenna. Again, okay, on the side view, you can imagine that they are almost the same. So this is actually from the side view. Okay, so basically this is for the omnidirectional antenna. And last but not least, when you actually take a look on the XY plane, which means that from the top, you look at the radiation pattern. Okay, like I mentioned earlier on, it seems to be like a donut shape. There will be a hole over here, but you can see that it is not a perfect donut shape. So this is actually the radiation pattern for small omnidirectional antenna. Guys, before I continue onto the Yaki antenna, I need your help. I need your help to like this video. When more of you guys actually help me to like this video will have a better chances to reach out to a larger audience. So guys, help me press the like button now. If you have learned something from this video, I will strongly appreciate that you can help this channel by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. The last radiation pattern from the Yaki direction antenna, okay, like the name implies, you can see that this antenna, in fact, is very directive. Okay, so basically, this is actually the RF energy radiate at a particular direction. So basically, you can imagine that the RF energy actually radiate at this particular direction. So this is for the Yaki direction antenna. Let's take a look on the radiation pattern again on the tree view, the XZ plane, YZ plane, and also the XY plane. This is from the front view. Okay, so basically this is actually from the front view. You can see that the radiation pattern look like this, and if you draw in a 2D manner, this is in fact the radiation pattern for Yagi direction antenna in the XZ plane. Now let's take a look on the YZ plane, which is from the side. When you actually take a look from the side over here, you can see that this is actually the below over here. Okay, and you can see that this is actually the top portion over here. Okay, so basically this is the so-called the YZ plane for Yagi direction antenna. And last but not least, let's take a look on the top view. Okay, when we actually look from the top view, okay, you can see that this is in fact the radiation pattern for the Yagi direction antenna. And if you draw in a 2D manner, so basically this will be the radiation pattern for the Yagi antenna in the three so-called diagram under the XY plot, under the YZ plot, and last but not least, under the SZ plot. Okay, so basically this is what I mentioned earlier on. This is actually looking the direction of the antenna at the three different plane, at the SZ plane, at the YZ plane, and last but not least, at the XY plane. Let me draw a conclusion on the discussion of the radiation pattern of the antenna. So typically, 2 or 3 view, okay, the cross section are shown. So basically, we can look from the top, we can look from the front or at the side. The XY or E plane are looked from the top down, while the XZ and YZ, or known as H plane, are in fact looking at the front or the side view of the antenna. The scale on the diagram, in fact, will be the key point to look at. The scale indicate at which the point and what direction the signal are strongest or maybe the weakest. So in short, over here you can see that a signal below a 3 dB line, in fact, they have 50% less power as compared to the input. And this thing go on and on. But in short, over here, you can see that these are the scale. Normally, they are in dB, and in specific data, it can be as dBi. So when we actually compare the radiation pattern of an antenna against an isotropic antenna, then it will be indicated as dBi. As for so-called isotropic antenna, they will radiate in this red line as shown over here. So this is actually the reference line for the perfect isotropic antenna. Signal actually emit from the antenna are 100% of the input. In conclusion, the diagram, okay, which is the radiation pattern, they are in fact a very useful guide to antenna performance. And in fact, they will show the direction of where the energy is emit the most, okay, which is mainly for directive antenna. It also shows how much energy is emitted compared to the input power. And basically from there, we are able to determine the antenna efficiency and also what signal direction are in fact the weakest. When the diagram contains multiple frequency, each loop on the diagram is normally represented by a different color, which I had shown it to you earlier on. And in fact, the different color actually represent a particular frequency. Sometimes the diagram actually show a gain. Okay, so in this case, the 0 dB point on the diagram is not the outer edge, and anything above that point is gained through directivity. In another word, at the expense of power in another direction. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.